Okay, today we are gonna do number theory part, right? 3.3 is about what? What is it? Just prime numbers, okay. You just wanna first ask the number 5, right? Okay, number 5. They want to find the product of all prime numbers, right? Product 1 and 80, right?
So I listed them.
Is divided by 10, and then they want to find what? Okay, before finding the limit, just prime numbers, the product, but they just ask when you divide it by 10, that time what is the remainder, right? Which means you just only check the ones digit.
So you divide them?
No, you just check the ones digit to get the remainder when you divide it by 10. Like this one, 345 divided by 10. What is the remainder? Just 5. You say just one digit, that's it. You understand me? Any number, like 1, 2, 3, 4. 1,234 divided by 10. What is the remainder? Yes, it's just 4. So for this number 5, 3.345a, you first copy the prime numbers, okay? Between 1 and 80, right? Like what? 2. Like what? 3 and 5. You don't write them all, okay? And the last one is maybe 79, okay? But you don't need to multiply them all. You just consider only what? One digit, right?
So you add them together?
No, multiply. They said like the product. If you multiply them all, you will multiply these 2 and what? So what is 2 times 10? Which means I don't know the like first or some digit, but the one digit must be? Yes.
Oh, because you multiply by 10.
I said it, that one is tricky. So when you divide it by 10, remainder must be? That's it. How can you multiply them? They're like all prime numbers.
Tricky.
Yes, tricky, you know. You understand?
Yeah.
And what is next?
Divide by 4.
Divided by 4. They just want to find out the product of prime number, but they just want as divided by 4, right?
Mm-hmm. Is it better to find?
So you just, how can you check the like divisibility of 4? You just check the last 2 digits, right?
Yeah.
You understand me? So you need to concede last 2 numbers, right? Okay, hold on a second. So can you give me some idea? So anyway, for the prime number, that is 2, right? Right?
2.
So must be even number. So when you divide it by 4, this product, P, divided by 4, that time you have no choice. So remainder can be what?
2?
No, 2 is impossible because this is even number.
Yeah.
So which means that the remainder can be 1 or 3.
Why can't it be 2?
Because P, the product P, okay, has 2 as a factor, which means if this P is what? Even number. You understand me? If you
multiply all of them, it should at least end with
yeah,
an even number.
yes. So you just consider 1 or 3 like that, right? How can
it be 9?
What?
And other numbers, like, does it always have to be 1 or 2? 3?
1 or 3, I said.
Only?
Yes. Or can be, I'm sorry, just can be 0, but it's impossible because there is no more 2. Only 1, 2, right?
Yeah.
You understand me? All others are just odd numbers, right? And also those prime numbers except 2 has no factor of 2. You understand me? This P product must be even, you know? But there is no more just 2 for the like other prime numbers, right? So you can first guess, oh, maybe 1 or 3. How can you get the remainder? So basically, when you get the remainder, when you divide it by just divided by 4, that you just look only last 2 digits, okay? Last 2 digits.
Oh, wait, then you just do 2 divided by 4? Like something like that?
No. Why'd you say 2 divided by?
To get an example of what remainder.
Oh, I'm sorry. The answer is just 2. You already told me that. This is my bad, okay? I mean, basically, when you get the remainder, I mean, if you want to find the remainder when you divide it by 4, okay, that you just check like last 2 digits, right? But it is too hard to get the last 2 digits. You understand me? Because there are a lot of numbers. Understand me? But simply, you can get like 1 digit because of 2 and 5, right? You understand me? But you can get some information. Oh, this P is what? Even number, right?
Just 2.
Yes, so remainder must be 2, right?
Yeah, because it's even.
Yeah, even number. For the even number, when you divide by 4, remainder can be like 0 or 2, right? But to say the 0 as a remainder, that number must be multiple 4, right? But for the, no more 2. Okay, only 1, 2, right? Just the even number, not the multiple 4s. Okay, understand me? Even though they just ask a product, but it is too hard to get the product. And also to get the remainder, when you divide by 4, that time you can first check the like last 2 digits. But for this problem, it is too hard to get the last 2 digits. Understand me? So you just try to get the kind of the secret for this product P. You understand me?
Can we do another example of the number 5?
Number 5.
Yeah, just to get the hang of it.
Just only same thing.
The same thing.
It's like if they ask the product of all prime numbers between 1 and 1 million,
Divided by 10 is still.
0. How about the divided by 4?
What about divided by 3?
3 must be 0. Because
Oh, yeah, there's 3.
how about divided by 6?
2 and 3.
So 0. Because this product must be the multiple of 6. How about 5? 7, 0. 8.
8, 2, 4.
Can be 4?
No, 2.
Just 2. How about the 9?
3.
Just 3. How about 10? 0. How about 11? 0. 12, 3 and 4. Right?
Yeah.
Divisible by 3. But when you divide it by 4, 2. So what does that mean that?
2.
Maybe 2. Right? Like that. There's no more example. They can ask that divided by 2, 3, 4, 5, like that, okay? So usually, most students try to, okay, how do I get like a product of those prime numbers? It is too hard. But they didn't ask the product. They just asked what? Remainder.
Yeah.
You understand me?
Yeah.
오케이, 조금 미스테이크도 있지만 그냥 우린 그냥 가.
넘버 7만 물어볼게요.
Number 7.
이해가 간 것 같은데 정확히 안
Okay, you want to solve the number 7. Suppose P and Q both represent prime numbers, such that like this one. They want to find the value of the prime P, right? So for the sum algebra expression, how can you understand like this one, okay? Like this one. How can you understand the 5P? How can you say that this is 5p? 5 times some prime number. What does that mean to 5p?
It means that it should be at least ends with 5 or 0.
So simply you can say, oh, 5p stands for like a multiple of 5.
Then 7q is also multiple of 7.
Yes. So I just want to rewrite this one. How? They want to find the p, right? So 5p is equal to what? 109 minus 7q, right? To get the p, it depends on q, right? But I'm going to use this all. This left-hand side is, when you divide it by 5, just a 0, right?
Yeah.
So right-hand side also same thing. When you divide it by 5, must be what? 0, right? Because this 5p.
But you just divided it.
No, I'm talking about the 5p stands for the multiple 5, right? So right-hand side also must be what? Multiple 5. I'm talking about that, okay? So even though they just use this one is what? 109, but for this 109, when you divide it by 4, what is the remainder?
It's a multiple of
105 is, I'm talking about only 105. 109, sorry about that. 109, 109, this number. When you divide it by 5, what is the remainder?
5. It's 4.
Yes, this is 4, right? But this one remainder 0, right? To make the remainder 0, for this number, when you divide by 5,
It has to be
4, right? But this q must be what? Prime number, right? Okay, that time you first check this 7. 7,
4. Oh, then it should be 49.
yes.
So q is 7.
Yes, because like this one is, even though this is 7, but when you divide it by 5, that and this remainder 2, right? To get the remainder 4, you need to make the something 4 or something 9, right? But simply you can use what? 7 as a value of this q. 2 times 7 is 14. 14 is divided by 4, remainder is 4, right? So basically this right-hand side must be multiple 5. Understand me? So basically 5p is equal to 109 minus 7 times 7, 49, right? But you have to check the p is prime or not, okay? Because that is another possible value, okay? This one is like 60, right?
Yeah.
So p is 12, right? Oh, doesn't work. It doesn't work. Because 12 is not prime. They want you to find the prime number, okay? Understand me?
Yeah.
So you need to try another possible value of the q. But that number must be prime.
14.
14 is not
5,
prime.
17.
17, yes, 17, okay? This case is a q equals to 7, right? But you can try another one. Something 7, so 17, right? So that time 5p is equal to what? 9 minus 7 times 119. This one is a negative number. So 7 is not good. 17 is not good. So you need to use another prime numbers. If you don't know, you just copy it, okay? 2 works, right? Right? Yes, you can use q is like 2, 3, 4, 5. I'm sorry, not 5. Like this, right? But you never tried the 2. If p is 2, this is 14, right? 109 minus 14 is 95, 5, right? That one is 5p, so p is none. 10 and?
19.
Yes, 19. So the answer is 19.
I don't know how I got that.
Yes, luckily you just tried.
Oh, I did too.
Yes, you can try Q again.
Oh, I guess.
Yes, you can first try. Okay, Q is 2, Q is 3, Q is 5. Like that, all right? Understand me? But there are a lot of possible things, right? You understand me?
Yeah.
So 17 is not good. this Q must be like less than 17 because this is already 109, right?
And then 17
Yeah.
is bigger.
But for the other problem, how can you understand like this one? Understand me? That you can use the divisibility. You understand me? Backward idea, you can also use it, okay? I mean, this case, we first try to use like a Q value, right? But if you want to find the Q, you can use a P value first, okay? Understand me? That time you need to solve for 7Q. Understand me? So like this, 7Q is, you can also use this one, 109 minus 5P. So you can understand that this is a multiple what? Oops, sorry. This number is multiple of 7, right? So how you just check that? How about this 109? If you divide it by 9, 7, 136. So 5 remain the 1, right?
Yeah.
Understand me?
Yeah.
Yes, you can do, man. Is it? No, not 1.
Wait, isn't it?
Oh, no, 30. Oh, my God. Just 4? Just 4. Sorry about that.
And then 5. That's the same thing.
Yeah, same thing. So to get the p-value, this 109 has remained 4 when you divide by 7, right? So for what value of p, this 5p also have remained of 4. You understand me? So unfortunately, there is, even though there is like a divisibility of 7, but that one is a little bit hard. So you just keep try again. You understand me? So I'm talking about you better use this one because you know the divisibility, okay? Easily. Understand? Okay. No more question for this section, right?
Mhm.
Okay, how about the next one? We can go to,
I got all the
I'm gonna touch the,
multiples are good.
how about the prime factorization part?
Prime factorization.
Mhm.
I did it up to F. I got it. I didn't.
Don't you have any question for the like that?
I haven't been able to finish it.
Can you easily get the prime factorization for the sum number?
You just have to use like multiples.
Just you can use the divisibility, okay? Okay. I'm gonna touch it like, even though you just did it, but I just wanna show that how easily get the prime factorization, okay?
Yeah, I only do it.
Write that on. Sometimes good. Okay, you just compare, okay? For the like 72. Yes, even though you can start like 2 times something, right? But you can use like a perfect square number like that one, okay? So I'm gonna use 9 and 8. 8 is 2 cubed, right? 9 is 3 squared. Simple, you got that. Understand me? How about the 243? That one is divisible by 9, right?
Yeah.
Because, yeah, some of them, not even numbers. So this one must be 9 times something, right? Mentally, we are going to divide it, okay? 20 something, right?
20.
Right?
Yeah.
And 7. So
But that's
basically,
like,
9 times 7 is
Oh, right,
63.
yeah.
So this one is basically 3 to the 5th power.
because 3.
So which means if you know the like knew the like this number is the 3 to the some power, you can easily got that up. Understand me? How about the 539? not divisible by 2, 3, not 4, not 5. You just try to 7, right? 7 and 7, right? And 7. So this is 7 times 11, right? And also you can easily check the divisibility of the 11. You know that? You can add up alternately. What is 5 plus 9? 14. And this number is 3. You just get the difference. What is it? So this number must be divisible by 11.
Yeah, I didn't learn.
Okay. Oh, now I'm gonna check the like a number 2. Okay. This one. Look at this number. Even though 6,886, that one is just even number, right? You can do divided by 2, right? 4, it doesn't work. But I want to say that this one is divisible by 11. How? Like this way, alternate digit sum, okay? You can first do 8 plus 6 is 14. How about this one? What is the difference? So 0 means 0 is always divisible by any number, okay? So this one is the divisibility of 11, okay? So you can divide it by 11.
So you go in between numbers?
Yes.
So you can't do it if it's like 530, 66,880.
66,080. Yeah, this one also same thing. Alternate, okay? I can give you the y, okay?
But there's another number, 66,886. 66,886.
I like this one.
Yeah. You can do it, right?
Yes, also you can do it, but in this case, not divisible by 11. But you can also get the remainder, okay? How? You can just use this one is like as a positive number, okay? So 6 plus 8 plus 6, okay? I'm sorry. For the 10th digit and the 1,000 digit is like a kind of opposite, okay? Like this way. Yes, kind of that. So you got the 6. With this 6 is sensible. When you divide it by 11, remainder is 6. Like that. Understand me?
So you add them and then you subtract.
Yeah. This one is like what a modulus arithmetic, you know? You will learn that one, okay? But now I'll just give the tip, okay? Without the dividing, you can easily check the divisibility and also remainder, you know? Most students try to find the remainder, just the dividing, right? But I don't want to get the quotient. I want to just check the divisibility of 11 and also remainder. That time you can use this idea, okay? Anyway, for the number 2, they want to find the largest prime factors, right?
Yeah.
So even though this number is divisible by 2, right? But you can also check, oh, this number also divisible by 11. So you can divide it by what? 11, right? So you can first get the 600, right? And 20 left, so 20, right? And the 6, right? Yes. Understand me? So, and then you can divide it by what number?
Can I give it to you by 6?
No, not 11, not doesn't work.
It's not even.
Even number, so you can do 2 because you don't know the other factor, okay? 3, 1, 3, right? So how can you check the like a little bit big number is a prime or not? You just try to, you can first try to divide it by 7, okay? 7. If you divide it by 7, 31 divided by 7, 4, 28, right? 33 left, so not divisible by 7. How about 11? I said no, right? So you can use 13.
But it can't be over 5, 6.
6?
Because 16. Because 16 times 16 is.
Yes, like that one, okay? Until one number, you just check that, okay? So you can use 13. And the next prime number is what? 17. But the 17 square is 287, 89, so you can check the 17 also. Understand me? But the 19 square also. 90, oh no, 90 squared is a little bit big number, okay? So you can first check that this number is divisible by 13. Can you do mentally? 31 divided by 13 first, okay? 2, so 26, 53. 53 is not divisible by 13 because 53 is already prime number, okay? So you can, next prime number is like 17. You can, if you divide 17, just only 17. So that time, 143, okay? 143 divided by 17 is, you can use 17 times 3. So you can first try this one, okay? 153, but right? So this 313 is just a prime. You can say that. Understand me? Usually for the big number, how can you check that this is prime or not? That until nearest like this number. Okay? You know what I'm saying? So like you remember the 17 squared? What is it? What is the 17 squared? 196 is just 14 squared. 15 squared is? Yes. 16 squared is? No, 296. So you have to know the for the like what prime number, just the perfect square numbers, okay? I can give you 15 squared. You know this one, right? 225, right? 16 squared. 296. One number did you add up to get the 296?
You have to add up.
I'm talking about like what is the difference between these two numbers? 69, right? Understand me? What is the 17 squared? At that time, you just add up the next other number, 71. Oh, next other number? Is it? It's the difference is 69, right? Oh, 16 squared is so not the 296. What is the 16 squared? You can also yes. 14 squared is 196, right? How can you get the 16 squared? I just want to use this one. 60 means like
256.
yes, 256. It's the difference is 30, 31, right? 39, right? Or 29, please. 29. I just want to give the some idea, okay? Anyway, this is the 256. Its difference is what? 29. To get the next perfect square, I just want to give the some idea, okay? You just, yes, you just add up the 31. So,
it's 280.
이거 틀렸잖아. 이게 31이야. 33 이렇게 해야지. 자꾸 이상해. Difference is 31, not the 29. 쌤도 해야 되는데 자꾸 네 말만 듣고 해서 어떻게? 289. 생님만 알고 있긴 있었는데 자꾸 물어보는데 이상한 말을 자꾸 하네. 그래서 쌤이 팁을 주는 거야. 왜냐하면 자꾸 multiply 하기 힘들잖아. But you know this, right? Using this one, you can get the next perfect square number. To get the next perfect square number, you just add up the next odd number, okay? What is it?
It's
324. Okay? You understand me? This is kind of...
You can subtract it to find 14, right? You subtract 29.
yes.
Oh.
You don't know that?
Never.
I just want to say it like this one. How did you understand the like a perfect square number? Yeah, just perfect square number. But the perfect square number always the sum of the first some other numbers, right? This one, look at that. 1 plus 3 is Yes, 4 is 2 squared.
잠깐만.
Plus 5, 9. Oh, 3 squared. 7, 16. Oh, 4 squared. 이거 다 레코드 돼. 그러니까 이게 약간 넘버에 대한 시크릿을 좀 알면은 막 이밸리에이션 하는 것보다 좀 재밌게, 그렇지?
Then 1 times 1 is 1. So when you add 3, it's
그래서 이런 아이디어도 가끔씩 써. 그러니까 보통은 좀 배운 보험 사람들은 알긴 아나. 이거 아는 사람들도 되게 많아요. 무슨 말인지 알겠어? 그러니까 선생님이 우리랑 할 때 이거 했잖아. You know like 25 what? Square right? 625 right? 네. So this one means sum of the first what? 25 odd numbers. I just want to ask you, what is the 25th odd number? Can you know that? So that time you can first say what is the 25th even number? 25th even number is no 25th means 25 times 2. 50 is 25th even number. So
51.
no. Odd number begin with 1.
Yeah.
So 49 is 25th odd number.
Oh, you subtract 1?
Because odd numbers begin with 1, 3, 5, like this one, right? Even number 2, 4, like that one, right? This is the first odd, this is first even, right? What is the 25th even number? Just 2 times 25, right? 50, right? So what is the 25th odd number? Just 49.
Why can't it be 51?
야, 이거 보고 네가 understanding을 높여. This is first. This is first odd number. This is first even number. First even number, odd number always less than the first even number. Okay? Nth odd number always one less than the nth even number. Right? 이런 것도 물어보면 잘 몰라요. 대답을 못해. What is a 100th even number? What is it? 200. Okay? How can you get the 200th, 100th odd number? That you can first try to find. 그렇지, like that. 그러니까 바로 네가 100th odd number를 찾으려고 하면 힘들어. 그러니까 even number를 가지고 하고 하는 거야. relation을 잘 알아야 되는 거지. 알겠어요? 이거는 odd number counting 할 때도 쉬워. 그러니까 you already knew the something 5 squared, right? So using this one, what is 26 squared? Even though you can use another idea, but this is 625 plus what? No, next odd number. So 676, right? 약간 이렇게 어떻게 number understanding하고 내가 어떻게 evaluate 하느냐는 거지. 그러니까 무조건 26 squared. I can do 26 times 26. Yes, it's okay. 근데 조금 더 넘버를 재미있게 어떤 친구는 이렇게 할 수도 있어요. 26 is 25 plus 1, right? Each square is like what? 25 square first. What is it? 620. And then 2 times 25, 50, right? And then you just add a 1.
Wait, what about 27? Then you do 25 plus 2.
25?
So like,
Yes, you can also use that. 이것도 쓰되 27 squared. 그러니까 넘버를 무조건 multiply 하지 말고 이렇게 보고 you know the perfect square, right? First one squared 625. You can first multiply this one 50, right? And then times 2 100, right? And then 2 squared 4 2 squared. So 729.
that's so cool.
그러니까 자꾸 이렇게 넘버를 조금 봐야지 하이 레벨에 갔을 때 무조건 이렇게 하지 않고 이렇게 퍼펙트 스퀘어 넣으면 포일 하는 거, 그지? 그런 것들도 계속 practice를 해야 돼. 그러니까 다른 컬러로 쓸게. 이거 다 뭐 다른 친구 보고 안 보고 중요하지 않아. A plus B squared is like what? A squared, right? 2AB plus B squared, right? 그러니까 여기서도 A squared, this one. AB first, 50, and then double, 100. Okay, if you memorize like those numbers, 625 plus 100, or 725, and then plus 4, or 729. 자꾸 이렇게 멘탈 매스도 해보고, 자꾸 트라이 하다 보면은 넘버들이 잘 보여. 그러니까 조금 그냥 재미없는 넘버들로 그냥 subtraction practice 하는 게 아니고 이렇게 하다 보면은 넘버들이 조금 재밌게 보이고 넘버 하나를 보더라도 그냥 뭐 이렇게 하는 게 아니고 계속 해봐야 돼. 이런 practice를 하면은 언제부턴가 넘버들이 잘 보이게 돼. 알아들었어? 뭐. Look at other problems. Okay, hold on a second. 다시 할게.
여기서 얘기해 준 거예요. 여기서.
What is that number?
It has 220 digits.
Which one will you try? How about this number? And this one? Okay. No, it's just almost same thing. So I just want to try the only number 3, okay? Understand me? They already gave you the prime factor of the 54,000, right? For the 54,000, how can you get the prime factorization? This one is like a 54 times what? 1,000, right?
Yeah.
For the 10, 100, 1,000, like a 10.
So you could just use 3, 4, 54, and 2 and 5 for 1,000.
Yeah, I'm talking about that. So 10 is 2 times 5, right? 100 is
2 squared.
5 squared. 2 cubed, 5 cubed, right? This one is?
2 squared.
Yes. So for the like this number, even though big number, but this one is just what? 2 cubed, 5 cubed, right? How about this one? 6 and 9, right? So 2 and 3? 3, right? 6 and 9. 9, 3 squared. 6 has 2 and 3, right? So finally, 4, I'm sorry. I just copied the exponent. 2 to the fourth, 3 cubed, 5 cubed. I'm sorry, what is this number? 5 cubed. So x plus y plus z is 10, right? This answer is 10. So how can you understand the number? For the prime factor or prime factorization, that one is important. You know?
No, I'm already telling you this. I'm not ready. Yeah, right here.
You remember? 넘버를 좀 그냥 옛날에 그냥 했을 때는 뭐 그냥 별 생각 없이 그냥 했지. 근데 넘버를 보면은 prime 넘버가 굉장히 important 해. 그렇지?
I had a hard time trying to find out what prime number is.
You know the meaning of the word prime, right? Prime. Amazon Prime. What does prime? Oh, prime is like important. So in number world, the prime is prime number, just kind of the basic.
Yeah, because when people say, "Is this number a prime number?" I'll be like, "It's 1 to 10."
Okay, I just want to ask you, what one is prime?
No.
One is composite? No.
Wait, is it one is composite?
So usually in school, what is a prime number? Prime number is a number, positive integer,
That cannot be.
can be
That doesn't have one or more.
divisible by one and itself.
Yeah.
Because of that, some students, oh, 1 is also divisible by 1n itself. So 1 is a prime. Please, no. So I can say this one. Prime number means it has only 2 prime factors. Only 2 factors, okay? How about the composite number? Composite number means 3 or more factors. How about the 1? 1 has only 1 factor.
But it has, if you do 365 divided by 365 is 1.
What am I talking about? I'm talking about some number is a prime or composite, but the 1 is neither. You understand me? Because 1 has only 1 factor, okay? So more precise, you can say define the prime number. Prime number is positive integer has exactly 2 factors.
Well, 1,
Has only 1 factor, right?
oh yeah.
So it is not prime. How about the composite number? Composite number is a positive integer
3 or more.
which has 3 or more factors like that, okay? So in math world, to define some terminology, that time we have to define exactly, not confuse, okay? But the most textbook define the prime number like what?
1, 2.
Divisible by, and has a factor 1 and itself. Kind of confused, okay?
If the 1 is not a prime and not a composite.
So neither, you know,
I thought it was composite.
neither. Okay, did you try the number 4? They said what? What is the smallest possible perfect square? That is what? How can you understand the perfect square number? Perfect square number means something squared, right? But this number must have 4 smallest prime numbers, right?
2, 3, 5, 7.
2, 3, 5, 7. Right? But there must be perfect square number. You have to square them all, right? So 2 squared, 3 squared, 5 squared. I'm sorry, what is that? 5 squared. Yes, and the 7 squared. You don't need to evaluate that, okay?
Oh, you don't have to like multiply.
Well, you can do that, but I don't want to do. Not a big deal, okay? You can first do like what?
100.
This is 100. So you just only focus on what? 49 times 9. Okay. 1. Don't forget 8. 44 times 9 is 36.
45.
No, 36 plus 8.
30. 45.
36 plus 8. 44. Oh my. In your brain, like, okay, 36 plus 8, but you don't. 36 plus 9. And then you just attach what? 2 zeros, right? Look at that. 2 squared times 5 squared is just 100, okay?
Oh, what if it says what happens if we remove the word calculus? Then it could be negative too.
Perfect square number always positive. Yes, any number except like imaginary number.
They're so tricky.
Yes, usually one should say, oh, that one is tricky. If you recognize that one is tricky, never trick that, okay?
How does the answer to part A change? It doesn't change. Oh.
Okay, I want to go to next one. 이거 다 편집해야 돼. 아, 편집하기 귀찮은데 이거 편집하니까 옛날 유튜브 할 때 편집하는데 너무 오래 걸려갖고 중간에 비디오 갖고 딱 자르게 잘라야 되는데 이거 맞추는 게 되게 귀찮아. 그래서 막 올리는 거야. 그래서 우리끼리 하는 이야기도 다 올리는 거야. Natural. 오케이?
자, 이게 컴퓨터가 다 복용되는 거예요? 아니면
근데
목소리만?
보여줄게. 아직 조금 끝나고 나서 하나만 더 하고. 이거 하려면 뭐냐면은 이게 레코드 하는데 조금 시간 걸리거든 얘네들도. 한 거 보여줄게. 다른 사람 한 거.
저는 유튜브 하는데.
니거 이거 한 거 올려 그러면.
네?
쌤 거 한 거 올려. 네 목소리 들어간 거.
내 학교 친구들이 있어요.
친구들 보면 어때? 뭐 이렇게 올리는 게 자신 없어? 내 부끄러운 모습이야? 아니잖아. 그럼 올려도 되지. 쌤이 처음에 우리끼리 하는 얘기 좀 처음에 유튜브 할 때 너무 잘 만들려고 막 한다고 해서 나만 satisfy 한 거지 다른 사람이 특별히 좋아하고 하는 건 아니더라고. 그러니까 우리가 어떤 일을 할 때 생각을 딱 해보면은 이거 마음에 들으니까 일단 뭐 자기가 좋아하는 것도 물론 중요한데 자기가 좋아서 한 것들이 남까지 다 좋아하진 않아. 물론 뭐 남을 신경 써야 되느냐 안 되느냐는 또 다른 문제겠지만은 어떨 때는 그냥 하는 거야. Just do it. Don't think too much. Okay? 뭐 우리가 이상한 짓을 하는 것도 아니고 뭐 쌤 봐봐 처음에는 영어로만 해야지 막 하다가 머리 아파. 그래서 한국말도 하고 영어도 하고 다른 사람 다 볼 것처럼 만든 거 아니니까. 어쨌든 this video는 only for you야. 다른 사람 보고 안 보고는 중요하지 않아. 뭐 보는 뭐 우리가 뭐 이상한 짓을 하는 것도 열심히 공부하고 이야기하고 그지? 그래서 가끔 뭐 내가 우리 킴벌리가 얼마나 예쁘고 멋있게 생겼는지를 이야기해주고 싶은데 카메라에 안 오고 싶어 하니까 일단은 넘어가고 어떤 넘버 트라이 해볼까? 6 해봐? 6 했어? 다 할 수는 없어. 다 하려면 시간이 좀 걸리니까 네가 좀 물어보고 싶은 거 여기까지는 피니시 해야 돼. 어떤 거?
For number 8, the exclamation point.
The factorial, okay?
You don't scream. You multiply 1 times 2 times.
Yes. 이거는 you can meet like this expression for the counting problem, okay? Okay, next time 하고 anyway, even though this number is so big,
You could just divide by 5.
they want to find like what? For this 40 factorial, you can get the prime factorization, right? Understand me? This type of thing is popular for the like AMC competition problem. Even though we get the like exact prime factorization, but individually, you can get like 2 to the y power. We can find this one, 3 to the some power. But for this problem, they want 5 to the y power. You know what I'm saying? That time you just consider how many multiple of 5, and also you just consider how many multiple 5 squared, like that, okay? How many multiple 5? So that time you can use 40 divided by 5, right? So 8. So you can get the 5 to the 8th power, right? But there is another 5, like 25, right? Because 25 is multiple of 5, right? But this is 5 squared, right? You will get another 5, right? Is there any multiple of 25? No, because until 40. So no more, okay? So this one must be what? 9th power. How about this one? So that time you can first think, 4 divided by 2, so 20. There are 20 even numbers, right? And also you, yes, divided by 4, so you get the 10, right? And also you have to divide it by, 8, 2 cubed. The multiple of 8 has 1 more 2, right? This is 5, right? Understand me? And 16. 16 is 2 to the 4th power. 1 more 2, right? How many? Just almost 2, right? How about the next one? 2 to the 5th, 32. So you got the what? 1, right? So you just set up 20, 10, 5, 2, and 1, right? So 38. This is 38. Like this way. You can find it. So using this one, I don't know this one, but how many zeros after multiply? using this one. There are what? 9 zeros. Right? How did you know that? 2 times 5 is 10. Okay? 2 to the power. That power is enough. You just only consider 5 to the watt power. They can also like this way. Understand me? How about B? Terminal zeros, okay? For example, 40,000 has how many zeros? Just like this. I already asked it. We already got the answer for B. I just expected, you know? So 9.
Because it's 2 times 5. But if it was multiple, oh, it's the same thing.
Say what? You didn't ask.
If you did what is the power of 2,
Mhm.
then you will still get 9 theorems. Yeah.
I said just 2 to that power is enough. You don't care about that one, okay? If you want to find like a terminal zeros, how many terminal zeros, you know? So that you just only consider 5 to the watt power in prime factorization.
When they ask you the term terminal
Zeros, like, understand me? Even though this one is, those problem is not a topic in school things, but for the AMC, that is kind of a popular one. They want to know this one, you know? So why? Because like, I just want to, how did you understand the number? Number? Just number. Like this one. What are you? I'm just Kimberly. That's it. If I ask who are you? Yes, I'm Kimberly. But if I ask what are you? You have to say about you, right? I'm just like, you're what grade? 7th grade. You will take an AMC 8. Okay? You won't. You have to got like your own goal.
I tried.
Yeah, try. But your best.
I tried my best.
Don't scared like a failure. You know, you just try. I said just to do it. That's it. Pass, fail, it doesn't matter. Okay? That's not important. Somebody said that like for the some things, there is only success or failure. No, I want to say the success and process. Okay? Okay.
LCM is kind of easy though. LCM, you just have to do this